Hey everybody, we're going to get the webinar started in just a couple minutes. For the best viewing experience, make sure to maximize the browser, and you can use the Control plus and Control minus key to zoom in and out if need be. We're in the chat taking questions throughout the presentation, so make sure you join the chat and get your questions answered. We'll also be hanging out after the end of the presentation for a live Q&A. Both Cameron and myself, Matt Doyle and Annie, will be hosting and ready to take your questions, so make sure you join us at the end. Thanks for joining, everybody. Talk to you all in just a second. Hey everybody, thanks again for joining our webinar. We're going to be getting started in just a second. It's going to be about a 45-minute long presentation, so make sure to jump into the chat and ask questions as we go. Also stay at the end. We'll be doing a live Q&A, and it's a pretty high-level overview of what it's like to work inside of Unreal Engine, making a mixed reality experience to run on the HoloLens 2. And we had a lot of fun building it. So I thank everybody for taking the time to check this webinar out and join us. So the first thing that you're going to want to do is go to the Microsoft GitHub page and find the Mixed Reality Toolkit for Unreal. On this page, you're going to get everything you need to create a Unreal Engine-based mixed reality experience on the HoloLens 2. And the main things that you want to grab are the UX tools for Unreal and the graphics tools for Unreal. These are going to work in conjunction with the plugins that ship with Unreal. So the HoloLens 2 engine plugin and the Mixed Reality engine plugin. So with that stuff downloaded, let's jump over into the editor and check out our project. So this is what the finished project actually ended up looking like. And this is using all that example content that we previously downloaded. We just imported in the PC components into that project. And it's comprised, again, of those UX tools, examples, and content. And those are going to be primarily for building the buttons and sliders and getting all the hand interactions and things like that hooked up. And then, of course, we're using the graphics tools example content. And this is stuff that's slightly more complex. That's going to give you improved visual fidelity for your mixed reality applications, while staying within the performance budgets of the HoloLens 2. And there's some really fun things in here like proximity lights, as well as some really beautiful materials that are very, very fast. And this MGT default lit is actually the main material that we're using to get the overall look and feel of that PC. And you can see that it's using a unlit shading model, so it's going to be very, very fast. And the main workhorse of this is this material function, this GT default lit. And really what this is an HLSL shader that the guys at Microsoft put together. And it just does a beautiful job. So that's going to be the main material that we're going to be working with as we build up the overall look and feel of this. So obviously we imported in geometry into the sample project, and that means everything was kind of set up. But if you had your own project and you wanted to go ahead and start to do mixed reality with it, there are a few things that you'd want to set up in that project. So the first thing you need to do is go into the plugins. And in the plugins, if you just search for mixed, there's going to be a variety of these plugins that you're going to want to turn on. And obviously, since we've based our project by importing geometry into an already existing project, these were already all turned on. But just go through, make sure those guys are all turned on if you're trying to do this with your own project. And then there's some project settings that you're going to want to turn on and off that are pretty essential, pretty important. So let's go ahead and just jump over into project settings, and I'll show you a few of those. So first one that you're going to want to make sure you have turned on is the forward renderer. So the HoloLens 2 is always going to use the forward renderer. By turning this flag on, it's going to basically make the desktop version of the editor also use the forward renderer. So you kind of want to do that so that you have a match and look. It's very important, actually. And then, of course, the vertex fogging for opaque is turned on. So those are a couple things. And then if you go and search for mobile, inside of mobile, there's going to be a few things that jump out at you. So the mobile MSAA needs to be turned off. This is something that HoloLens 2 just doesn't really want to have on, so make sure that's turned off. You're going to want to turn off the culling also, and you're basically going to then jump over into the VR section. There's a couple of important ones in VR. So let's just kind of grab that and scroll up here. So the instance stereo is turned on, and the mobile multi-view is also turned on. The mobile HDR is turned off, and this is pretty significant. We're going to see the effect of that being turned off in just a second here. So just this is one of the things that really changes the difference between the desktop renderer and the mobile renderer. So let's just go ahead and check that out now. So what we have here, obviously, is the finished computer. It's using all that, that unlit shading model on all the materials here. And if we wanted to see what this would look like more on the mobile or on the HoloLens 2, we can actually simulate that by jumping into Play and just playing this in Pi for the mobile preview. So as soon as we do that, it's going to kind of go out and launch this off. And we'll just kind of dock this window kind of over here. And then we'll make this one over here and just hit F11 to kind of zoom that up. So you can see that there's a pretty significant difference between the look on the mobile preview versus what would be on the desktop editor preview. And really what's happening with this is a lot of the information is being derived from this cube map that's sort of wrapping around the whole scene, that's giving us the ambient lighting and also giving us that kind of reflection lighting on the glass panel there. And obviously, because mobile HDR is turned off, it's going to not have quite as much contrast. It's going to be a little more flat and washed out. So really what we're doing when we're starting to do look development is we want to try to get the editor to match up with what's going on inside of the mobile device or the HoloLens 2 so that we can make informed decisions, right? So how do we go around this problem? Well, it's actually pretty easy and pretty straightforward. So let's go ahead and just exit out of that guy, and we can just zoom this back to full screen. So what we're going to do is we're going to actually go over to our settings, and we're going to switch our render level from Shader Model 5 over to Android. Now, yes, we're going to be running this on a HoloLens 2, and it runs on a Snapdragon processor, but it's actually kind of this unique little device that's running Windows 10. And even though it's a mobile platform, it's actually using Shader Model 5. So don't let this name confuse you. When you switch this over to the Android ES31, it actually is going to be pretty similar to what you're going to be seeing on the HoloLens 2 and on the mobile device. So by making that switch, you can see we now have a button up here, and that button allows us to toggle back and forth between seeing the preview of the mobile device and not seeing the preview of the mobile device directly inside of the editor, which is really pretty awesome. Now, because it got a little washed out, I'm going to want to adjust some color settings now that I've got this in this kind of better previewing mode. And when you're working on the HoloLens 2, because it's an additive device, you're going to want to make things probably a little bit brighter than you normally would inside of the editor. And things like black, they're going to be transparent, so you're going to push those black levels up into the gray. So we're going to make this a bit poppier and a bit more contrasty. And like I said before, a lot of the look and the feel of this is coming from a reflection map that's kind of wrapped around into a cube map on all of those materials. So the first thing we're going to do is we're just going to kind of pop that a little bit brighter. So if we jump into our textures setting here, and I grab this cube map, this is basically, this is actually the cube map that ships with it's in the engine content. And what we've got here is I've actually got that kind of cranked up a little bit brighter. So I'm just going to increase that a bit more. Brightness curve is, it's basically a power, right? So if we put this to something like 1.7, oops, not 17, that's going to be crazy. We don't want that. We want to do like 1.7. You're going to see that it's going to get a little bit more poppy, a little bit more contrast inside of there, and that starts to look a little bit better. Now, the other thing that I'm going to do is I'm going to go back into the light. So there's a directional light that is tied into that GT default lit material. This is a special light made to work specifically with that unlit workflow, and it's going to get a little bit brighter just to kind of, again, overdrive the overall effect of that. So once we do something like that, it actually starts to look pretty good, and that's a lot poppier, very similar to what we had when we weren't doing the mobile preview. And you can see how nice and bright that is, and I know that on the additive display that's going to pop out and look really pretty good. So the final thing that we're going to want to do is we're just going to escape this out. We're just going to go ahead and we're going to preview this instead of using the mobile previewer, just in the selected viewport. So when I do that, you can see that we get these nice little preview hands. I can move those around, and I can actually start to go in here and start to trigger some of the effects that Cameron had set up on this guy. So it's really very, very fast and easy to start iterating with these kind of virtualized hands of the HoloLens 2 device directly inside of here, which is pretty cool. Now, another thing that we can do really quickly is if we just type in stat RHI in this guy while this is playing back, you can see our performance. And, basically what's going on here is right now my triangles and my draw calls are a little bit high. So if I go ahead and I hit F11, it's actually going to give me a better read of what's actually going on inside of here. So the UI inside of Unreal is actually drawn using those draw calls and all the average stuff. So by turning it into F11 mode, you're basically going to get a true read of what's going on here. And having it around 100 draw calls and around 100,000 polys, is kind of the ideal range. And that's exactly where we're at with this data set here. It's a little heavy on the geometry, but it actually wasn't slowing it down on the device. We were totally fine. So that's the basics of getting your project set up and ready to work with the HoloLens 2. So we're going to talk about look development a bit more in depth now. Okay, so here we are at the very beginning of the look development process, and basically what I have is the PC after it's been imported in from the DCC. Most of the materials that are on the PC are currently using the standard Unreal materials that are set to default lit. There are a couple that have the graphics tools materials already assigned to it. I've also got 2 Macbeth charts in here that came from the automotive material pack that you can get from the content browser. The top Macbeth chart is using standard Unreal materials that are set to default lit. The bottom one is using the graphics tools materials in an unlit mode. And I've got a simple lighting model in here. So it's got the skylight with the cube map piped into it. So that's going to give us sort of our ambient light. And then I just have a little bit of a directional light in here to give a little bit of warmth and a little bit of pop. So a very simple basic lighting model that's going to look good on the HoloLens 2. Now, obviously, if I start to increase the intensity of this directional light, it's going to affect the materials that are set to default lit and not affect the materials that are the unlit materials or the graphics tool materials that came from Microsoft. So what we want to do is ultimately we want to get this PC all dressed with the graphics tools materials, but I just wanted to show you kind of the basic lighting workflow and share with you a few tips and tricks along the way to kind of help you guys out. So with that done, the first thing that we want to do is obviously this Macbeth chart on the bottom does not have a directional light hitting it. So let's go ahead and get that directional light that works with the graphics tools added in. And this is easily done by going to the place actors and just searching for GT tools. You can see that there's proximity lights and directional lights. So we'll just drag and drop this in there. And it's a little bright, so we'll just put that down to a value of 1. And I want to get these guys to kind of copy the rotational value off of this light. So we'll copy that, and then we'll just paste it onto this guy so that they're kind of in the same angle. So these Macbeth charts now are starting to look a little more similar. And really the idea is to use this Macbeth chart to go ahead and really dial in that lighting, get your base lighting set. And this is pretty easily done using the Pixel Inspector. So if you go to the developer tools and bring up the Pixel Inspector and we start to play this, it's going to give me just coordinates and not really kick back any color information. And the reason that it's doing that is because we're in the mobile preview mode. So as soon as we jump back to the desktop mode by muting that guy, you can see that it's now recording values, but the color changed a pretty significant amount between the desktop version and the mobile version. Here's a pretty cool trick. If you switch this to unlit, look at the graphics tools down here on the bottom and look at the change between these guys now. They're really pretty similar to each other. So by switching to unlit mode when you're in the desktop mode, it's going to allow me to use the Pixel Inspector to fine tune and dial in that gray value. And really what we want to do is we want to get these values right here around that mid value of 0.18. So how do you do that? Well, pretty straightforward. We're just going to take that GT directional light and start to increase its intensity. We'll go up to something like 1.3, and now you can see that mid value is kind of reading in the 0.18, except the blue. So it's a little hot on the blue. So you can also use this to really kind of fine tune where that white point is. So I'm just going to go back to that directional light and warm it up a little bit by pulling out a little bit of blue. And now if we go back and take another reading on this guy, we're really getting close to having that mid value kind of nailed, which is exactly what we want. So now we can jump back into the desktop mode and switch this back over to lit. So the next thing that I want to kind of talk to you guys about briefly is the way that these graphics tools materials are kind of using cube maps to simulate obviously the reflection as well as that ambient light. And what's going on is every single one of these materials, like if we double click on this guy and bring up this material, you can see that, on that material, it's got the cube reflection kind of added into it of that same epic courtyard. And that's going to happen on every single one of these, these albedo balls. And there's about 6 or 7 materials on there. So to have to go through and change every one of those maps if I wanted to switch the lighting model around can be a little tedious, right? So what I've done is I've come up with a nested workflow where I'm going to take a material instance of that base material and then nest that instance inside of all these other instances. So by doing that, it allows me to change just one cube map. So I've got this parent of all of these objects that are in that albedo chart. Let's just kind of move this over so you can see the change here happen. If we double click on the albedo cube map, you can see that it is actually now again, another instance. And if we double click on this guy, it's going to show us, the actual material graph. So it's set to unlit. It's using the GT defaults, and piped into that, I've got, a few things here. We've got the albedo going through a power. I've got the vertex colors also going through a power. So it's interesting. It doesn't actually use texture map information. It's using vertex color for that stuff. And I have a little switch that lets me, add some functionality into there. But for all practical purposes, this cube map that's part of this guy is what's being referenced in this initial instance. So by changing that one cube map on the albedo cube map, like if I just go and change this guy, like, I don't know, we'll just search for cube, and I'll grab this HDR here. You can see that, in one click, I was able to update seven or so materials. So really, really fast, easy way. And then if we just type cube again, we can get back to this guy right here. So with that done, let's go ahead and close that down. Let's just exit out of that guy, and let's just sort of zoom back out here. And you can see that once that mid value is kind of set, everything just sort of sorts to come together. It starts to look really, really pretty nice and pretty good. So the next thing that we want to do is we want to start to build up some more materials on this PC using the graphics tools. And I'll just show you how to do that. Again, pretty straightforward stuff. So let's go ahead and grab this, double click on that instance. We're going to go up to the master for that guy. And obviously this is set to use the default shading model, default lit. So let's just expand this out a little bit and push that PC over so you can kind of see the effect here when we do this guy. So I'm going to switch this to unlit. That's going to be great. It's going to be very, very fast. And then if I right click and just search for GT, you can see that I can grab the GT default lit. And that, of course, goes into the emissive color. And then we can just start to map these guys sort of back in here. So metallic and then roughness. And that starts to look pretty good. So if I hit apply on this, it's going to go through and it's going to update all the materials that master kind of, fed into. So if we kind of zoom out here and see a little peek of that PC, you can see that it's, it's kind of bright now. So this is looking pretty good. Now, really what I did to get the kind of overall lighting for this, I was playing around a lot with ambient occlusion. And what I ended up doing was taking all these components of the PC out of Maya into Substance Painter and baking lighting maps in Substance Painter that were very broad to give me this kind of nice diffuse lighting model. So let's check that out right now. Okay, so here we are in Painter, and inside of Maya, I went through and laid out all the UVs on this object onto channel 0. And then on channel 1, I've also got another set of UVs that are used for the color information, normal map information, and a secondary detail map for some of the objects that has ambient occlusion baked into that. So what we want to do is we want to basically bake a really nice broad AO pass on all this geometry. And this is super fast and easy to do in Substance Painter. So all you have to do is go ahead and jump over to the bake mesh settings. And I'm going to turn off all these other options for these maps. We don't really care about those. We just want the ambient occlusion map. And I'm going to bake that out for all the geometry in my scene. So you can see it's going to go through and in a matter of seconds, generate this really nice AO pass for me. And if we just switch this over to view here, you can kind of get a sense of, what's going on with that. So that's really what's going to give me that very nice diffuse lighting model, which looks really, really good in the device, in the HoloLens too. Having this sort of global illuminated AO feel to the holograms really makes them feel, pretty awesome actually. So let's go ahead and jump back over into Unreal and check out what those maps look like once they get applied. So let's go ahead and just jump over to my textures, and in my AO Painter, you can see there's all the texture maps. And what we're going to do is we're going to go ahead and just go back into that PC White master material. And in that guy, I'm going to just drag in this AO map into the ambient occlusion. And it's worth noting that, like I said, it's using the channel 0 for that map. So we're going to go ahead and just drag and drop this guy into the ambient occlusion spot. And if we hit apply on this, it's going to go through and it's going to add in that. And you can, you get that sense of that, AO being added into all these little parts inside of here. You can really see it, sort of up in this area and things like that. So it goes through and it does a really, really nice job of just giving that kind of nice global illumination kind of feel to that PC and to all the geometry associated with that. So let's move on to the next thing. So the next thing that we want to talk about are a couple of things that you can do to, again, help performance on the HoloLens 2. So we're going to go ahead and look at this motherboard texture map, and we're going to improve the look of this. It's really, really flat right now. And I'm going to do that by bringing up the master for it. And let's just go back into here and double click on that motherboard and load up this mTexture master. So what we're going to do is we're going to switch this over to be, again, using that GT Tools. So if we hit tab and search for GT default lit and change this model over to be unlit, pretty straightforward there. We'll throw that into the emissive color. What we're going to do is we're going to pipe in a few of these maps here. So we've got our color map, pretty straightforward. That's going to go into base color. And then I've got this funky looking map over here. And what this is this is just a map that's been combined together. So in one map, I'm carrying the color information for 3 maps. So by doing this, it's going to make things just be a bit more performant. Like you don't want to have too many texture maps going out to the HoloLens 2. So by joining 3 of these guys together, you can really get a pretty nice performance improvement. So on my red channel, I've got my detailed AO. On the green channel, I've got the roughness. And then on the blue channel, it's going to be the metallic. So by combining all of those guys together, it just saves a little bit of information, which is going to make things run a bit more performant on the device. So let's go ahead and just add in the roughness for this guy, as well as the metallic for it, which is pretty straightforward. And then for the ambient occlusion, what I'm going to do is I'm going to actually use these 2 different maps. So if you remember, I talked about the fact that on channel 1, you can see here my constant coordinate on channel 1 is set to, for the color information, the normal map information, all those guys are using channel 1. And then that broader AO map is using UV channel, the channel 0. So what we want to do is we want to multiply those 2 guys together. And that's easily done by just holding down the M key to bring up the multiply node and clicking with the left mouse button. And we'll just grab the red out of that. And then we can grab the red out of this guy and just shove that into the ambient occlusion. And it's going to give me, this kind of, hit apply on that guy. And you can see as it pops in there, the map just starts to look a lot better. And you can really get a sense of, that kind of reflection sort of crawling across there. And it just starts to look a lot better than it did. And obviously you can see the combination of those two ambient occlusion maps sort of multiplied together to give me that end result, which is exactly what we want. So the next thing that we want to talk about is tiling and how to get some performance if you've got meshes that have repeating textures on them. So this is actually really pretty awesome. This is a great tip. So I've got this mesh here. Let's go ahead and grab that guy. It's kind of hard to select. I think I got it. Perfect. Bring up the master for this guy. So you can see I've got my UV tile set to be 150 on that guy. So let's jump into this. And this is already set up here using the GT Tools, which is great. And you can see that I've got 2 different texture samples happening. So I've got my AO pass on 0, like we talked about before. And then if we look at this guy, the repeating mesh grid is happening on coordinate 1. And the way this is mapped right now, going into that texture sample, it's actually a pixel shader, right? And this is kind of costly. So we can actually do this UV tiling and repeating with a vertex shader. So how do you do that? It's actually really pretty simple to do and very, very cool. So if we go back to this material and we just search for custom, you can see that you can add customized UV. So if I put this to 2, I'm going to get the 2 texture channels that I need. And all I have to do is just unmap that guy. And this is still going to be even using the first UV channel. I'm just going to pipe this into the second UV channel. And just like that, now if we hit apply, that's going to tile and be much less costly because it's doing it at the vertex level instead of at the pixel level. So really, really fast, very, very easy workflow. So those are a couple little tips and tricks to get more performance out of your rendering when you're working with Unreal and HoloLens 2. So final thing that we got to talk about super quickly, we're running out of time, is just what the Variant Manager does and how that is going to get handed off into Cameron, so he can start building up some more complex UI elements. Let's jump. All right, so what I'm going to do is I'm going to get out of this look development level and get back into the more finished level that we kind of saw at the beginning here, so you can get a sense of what what this really does look like inside of the editor. Again, we're using the mobile preview, and it it really does kind of look. I think it looks pretty good. And in the device, it's super, super cool looking. One thing to keep in mind when you're working with the additive display, I think I might have mentioned this before, but if I didn't, you're going to want to make things maybe a little bit brighter than you normally would. Blacks are going to read as transparent, so those are going to need to be lifted a little bit. So just kind of keep that in mind when you're doing your look development work in the actual editor. So what we're going to do is just give you a quick overview of what the Variant Manager does, and it's already been set up in this scene. And since we're so quick on time and Cameron's going to be using this to build up, I'll let him kind of, show some of the wiring up of it. But essentially what the Variant Manager is a very fast tool that allows you to create options for objects in your scene. So you basically go through and create variants. So I have one set up for color and I have one set up for the cooler, and you populate these different variants with actors and you specify which parameters you want to have the Variant Manager watch. So what I've got here is I've got obviously the dark mode, and then I've got the light mode, and then of course we've got the two different variations for the cooler. So it can watch a variety of things. It's actually quite flexible. You can extend the functionality of it and do many cool things with it. So obviously we've got the air cooler already on, and if I click on the liquid, we could obviously go liquid with the dark. So these are the options that are the kind of set up inside of here. And again, it's just a matter of kind of dragging in the actors, specifying, what parameters you want. You could say add a property, go through and pick any of these properties, and then those will be also watched by the Variant Manager. So super easy, fast, straightforward tool to work with to build up these very complex relationships. So with that done, I'm going to basically hand it off to Cameron. He's going to take over and build some really interesting functionality and kind of use the Variant Manager and help him in building out that UI experience. So thanks again, everybody, and over to you, Cam. Cheers.
Hello everybody, this is Cameron speaking. Now that Daryl's provided us with an excellent base to work off of, we can start building out UI for HoloLens 2. And to do that, we're going to use UX tools and graphics tools. So if we look at the content within our project, we have a UX tools content folder, a graphics tools content folder, but then we also have UX tools examples content and graphics tools examples content. Now, most projects won't pull in these examples unless you want to reference them, which is exactly why we pulled them in. And we're going to look at the UX tools examples content folder. And within this folder, there's tons of different levels. Each one of these levels contains examples of a specific feature. I'm going to jump into the near menu level. So if we look at near menus, basically what they are, they're little panels that can either float around in 3D space or stay world locked to a certain location. And that's exactly what we're going to need for the PC. We just want a tiny little window that can contain a few buttons. So the first thing I'm going to do is select one of these pre-built blueprints and just duplicate it. So since I know I'm going to want 2 buttons along with maybe 3 to 4 other buttons on the side, I'm going to select the blueprint near menu 4x2. So if we browse to that, let's just duplicate it real quick. Duplicate it, and let's call this BP main menu. Alright, now that we have a main menu blueprint, let's create a level to place it in. Whenever working in mixed reality, I always select empty level because in mixed reality we're working with the real world, so we don't need a skybox or any other objects to represent our environment. So, with a new level selected, first thing you always want to do is drop a player start in. The player start in this situation will act as the origin of the virtual world and real world. So Let's just set it to the origin just to be clean. And then we will navigate to the main menu blueprint we just created and drop it in. So if I place that at the origin and hit play, I won't see anything because I'm inside of it. So what we'll want to do is let's place this a comfortable distance away from the user. About 40 centimeters is a comfortable distance for people to reach out at. So let's place it a little bit further than that. Let's say 60 centimeters away. And if I hit play now, you can see I'm facing the menu from behind. And that's just because a lot of Unreal components face along the positive x-axis. So to fix that, we'll just rotate 180 degrees around the z-axis. And now if we hit play, our near menu is right in front of us, and we can even hit a few of the buttons with our simulated hands. Next thing I want to do is create the actual blueprint computer. And since Daryl and I are working in conjunction on this, I don't want to step on his toes if he's making any other changes. So I'm going to create a brand new blueprint and just child from the blueprint that he's already created. So I'm going to name mine BP_computer, and I'm just going to drag that into the scene. We'll put this 60 units away, and then we'll just kind of move it off to the left a little bit. Maybe we'll rotate it a little bit just to kind of frame it nicely. So if we open up the blueprint, you'll see there's quite a few things going on in here. First thing is I'm going to set my near clip plane to be a little closer just so we're not clipping into ourselves. And this menu contains a few components such as a back plate, which is this blue background that our buttons sit on. Some grab dots just indicate to the user this is a grabbable surface. And then we have this button. So this is a toggle button, and it allows us to pin and unpin the near menu. And what we mean by pin and unpin is that basically toggles this follow component. What the follow component does is when it's not active, your hologram just sits in space and hangs out wherever it currently exists. But when the follow component is activated, the menu will move towards you and kind of hang out above your waist and always tag along with you. And that's great for situations where you need to maybe walk across a room and you don't want to have to carry your UI with you. It'll just follow you along. Another great thing about near menus is if you did want to carry them across the room, they have what's called a generic manipulator component on them. And this component is actually what allows you to grab the menu, pick it up, move it around, and you can apply this to any object in Unreal, and you'll be able to pick it up and move it around. So I've been talking a lot about buttons. Let's actually start configuring some buttons for our panel. So this panel will only need 2 buttons. So let's get rid of these other buttons. I'm just going to set these child actors to none to get rid of them. And then I'll delete these last 2. So that gives us button 5 and 6. Let's move button 5 right above, or sorry, let's move button 6 right above button 5. And to do that, we'll move this over to 4.8, and then instead of negative 1.6, let's make it positive 1.6. Remember, these buttons are 32 by 32 millimeters, so that's where the 1.6 comes from. It's half of 32 millimeters. So now, let's give these a name that means something. Let's name this one Explore, and let's name this one Config. All right. And then, if we go into the child actor template, we can actually label the button here. So this one is Config, and this one is Explore. Now right now these have icons that just came from the example, but they don't really represent config or explore in my opinion. So let's go and look at the label brush. So sorry, the icon brush. If we open up the icon brush editor, every icon on a button is just a glyph in a font. So you can pick any character you want. I think for config, let's do a bunch of sliders. That makes sense. And then for explore, maybe I think this compass makes sense for exploring. Perfect. And one last thing I'm going to do is right now, this child class is just using the normal pressable actor. I want these buttons to have state. I want people to be able to tell if they're on or off. And fortunately, we have a few button types that can do that. So right now we're using the normal pressable button actor, but we have a check button, radio button, switch button, and toggle button. What I want to do is use the toggle button. So I'm going to switch both of these to be toggle buttons. Let's compile, save, and let's hit play. And you can see how toggle buttons are different than normal buttons. So now when I press these buttons, they get this kind of light blue backplate on them. And that's exactly what I want to do to relay to the user that this button is toggled on. But one problem is both buttons can be toggled on at the same time or toggled off, and I always want to have one button on and the other button off. To do that, we're going to add a new component, which is called a UXT toggle group. And UXT toggle groups, they take an array of buttons. So let's take our first button, config, and our second one called explore. And we can give it an initial selected index. We'll say index 0 is the initial selected one. So now, if I hit play, we can see config is toggled on initially without me having to touch anything. And if I tap explore, config toggles off and explore goes on, and vice versa. So that's what I'm looking for. Now that we have two buttons to drive the tabs of our menu, let's go about actually creating the tabs. To do this, let's look back at the main menu, and we could just throw all the UI components into this blueprint, but this blueprint might kind of explode in size pretty quickly and get out of hand. So what we're going to do is create another child blueprint that's going to act as the first tab, and then another child blueprint which is going to act as the second tab. So first thing, let's create a new blueprint. We'll just inherit from actor. We'll call this bp underscore config. And the first component I'm going to add to this is the UXT UI element. And let's just make this the root. So UI elements, they are kind of a utility class that help us group UI into, I guess you could say, almost folders. And they have a nice library of functions such as hiding UI from being visible and interactable to either or, so being visible and not interactable or interactable and not visible. So we're going to use this functionality later, but for now just think of this as a container around a bunch of UI. So next, let's add a child actor, and let's call this, we're going to have 4 different config buttons for our PC. We're going to have light, another child actor, oops, let's add another child actor. We're going to call this one dark, and then another one for air-cooled, which is called air, and then another one for liquid-cooled, which we will call liquid. Okay. So, first thing we're going to do is we're going to make the light and dark buttons toggle buttons. Let's also add our air and liquid buttons. For these buttons, let's do something a little different. Let's make some radio buttons. These light and dark buttons, let's give them an icon that actually shows the color of the object. So I'm thinking for this, we'll just make a little dot, which kind of shows a color palette. Same dot here. And let's actually increase the size a little bit on these. So let's try about 2. Scale them up. And then for the dark, let's make the color a little bit darker. So let's try maybe a little darker than that. Like that. Okay. And then last but not least, let's give them a good label. Light, dark, and air, and liquid. And since we don't want to be light and dark at the same time, or air and liquid at the same time, we're going to add some toggle groups. So this is the toggle group for color, and then a second toggle group for, we'll call this config. So color, it's going to have 2 items, light, dark. We're going to start with light as the initial setting, and then same for this, air, liquid, and air as the initial selected object. Okay, so now let's set up our child actor for our tab. Oops, I put that in the wrong spot. Delete. We want this under the scene root. Child actor. Okay. BP config. So now these buttons all live on here as their own little child actor. Now, what I want to do is show this tab when config is selected and hide it when Explorer is selected. So to do that, let's jump into our event graph. And remember we made a toggle group for the Explorer and config buttons. There's an event called onGroupSelectionChanged, which we're going to use. And this event gets fired whenever Explore or config are pressed. So now when the group selection changes, we're going to key off the selected index. When it's 0, we're going to show the config tab. And when it's 1, we're going to hide it. So let's compile and save. And let's run this. So already we've got light selected and air selected. Now if I tap Explore, it hides, shows, hides, shows. Awesome, so that's working. So now that we have our main menu layout set up, let's actually make it drive something on the PC. Let's try to change the color based on these 2 buttons. So first thing, let's open up the computer blueprint. Let's make a new function called toggle, too many G's, toggle color. And it's going to take a color index as a parameter. Then for now, let's just print hello to make sure we're here. Well, let's print the index. How about that? All right. Now, this function needs to be called from the main menu. There's a few ways we could do that. Could use event dispatchers or blueprint interfaces, but to keep stuff simple, let's just do direct actor-to-actor communication. We had these 4 buttons: light, dark, air, liquid. Light and dark are part of the color toggle group. So let's create an event on selection changed. And we're going to grab that PC. We're going to call toggle color. It's always a good idea to make sure it's valid, so let's do that. So if the PC is valid, we're going to toggle the color, and the index is actually going to come from the selected index. So we're going to pass in 0 when it's light and 1 when it's dark. All right. So now that all the variants are hooked up, we should be able to touch the dark button, light button, and I've even gone to the effort to hook up the air and liquid already. So now when you select liquid, liquid cooling turns on, air cooling tools turns on. So here you can kind of experiment with all the various configurations. Next, let's look at the Explore tab. So here we have 3 buttons, 2 check buttons and 1 normal toggle button. The check buttons are used simply for turning features on and off. So we can show and hide the glass on the front of the PC, or we can animate the fans on and off. And last but not least, the placement mode. If I turn that on, doesn't look like much changes, but I'm now able to grab the PC and move it around. And this will actually use the spatial mesh on HoloLens to help you place the object in the real world. Let me explain a little bit more about what all these buttons do and what that means. So if we open up the Explorer tab, there's a little bit more going on here than the other, but don't worry, we'll kind of go through this step by step. So toggle glass and toggle fans do pretty much the same thing. They grab the show glass child actor, which in this case is a check button actor, casts it to a UXT toggle state component. Sorry, it doesn't cast it, but grabs the UXT toggle state component, and then simply binds to the toggled event. And that toggled event just calls this custom event, which grabs the PC and calls a function called toggle glass. And that function simply just turns on and off a static mesh. Toggle fans does the same thing, cast a child actor to a toggle state component, and then bind to the toggled event. And this calls toggle fans, which turns on and off a few animations. The real meat of this script is the toggle placement button. So what this does is same thing, grab the toggle state component, bind to an event, and I should mention this is all happening on begin play, so we do this once. And what we do is called toggle placement, and all that's doing, if we jump into there, is turning on and off the UXT tap to place component. So this tap to place component is pretty handy. It allows you to simply tap on a hologram, and that hologram then floats a fixed distance away from you and will interact with the spatial mesh. The one thing is, though, we need to turn on the spatial mesh. So to do that, we call start AR session or pause AR session with a specific AR session config. And then we loop through all the spatial meshes and turn them on or off. And this definitely needs a little bit more explanation. So let's look at this AR session config. So if we look at the session config, there's a few options in here. First one is generate mesh data from track geometry. So what this does is it tells HoloLens to use its various sensors to scan the world around you and generate meshes for the real world. So it'll generate messages for tables and walls and floors and ceilings. This next checkbox simply says don't only generate meshes for things to render, but also generate collision meshes for us to collide with. And then I'm just saying, let's render the mesh as wireframe, and my quote-unquote wireframe material is simply just an unlit material that returns a nice blue color. So when I say start AR session in the config tab, I'm using this config file to say, hey, start scanning the room, or pause, stop scanning the room. These are all using Windows MR. OpenXR is coming out in Unreal 4.27, and toggle AR capture will be the preferred method to do this. So once I've turned scanning on and off, the next thing to do is to toggle the spatial meshes on or off. And I have this kind of array of spatial meshes, and you're probably wondering, where is that coming from? That's coming from this component called AR Trackable Notify. This is a built-in component. And when you add this, it has three events which are useful. So there's events for adding new track geometry, updating, and removing. So I've subscribed to all three of these. When we add new track geometry, I simply push the track geometry onto this spatial mesh array. When we remove one, I remove it from the array. And then when we update any geometry, I grab the PC, or the Place PC button, to check its current toggle state to see if it's checked. And then I call this toggle spatial mesh function, which I wrote. And if you jump into here, what it's doing is grabbing the current geometry, querying its classification, because not only do meshes that are surfaces in the world come through, but also the mesh that represents your hand comes through. And if spatial mesh is enabled, I set its visibility true, I'll set it to false. And then if it's a hand mesh, we always want to disable collision on the hand mesh, just because we don't want the hand mesh to be colliding with any of our interaction raycasts. So no matter what, if it's enabled or disabled, we disable collision on the hand mesh based on its object classification. So unfortunately, this button doesn't really show much in the editor, but once we launch to HoloLens, I'll show you what this button does, and you'll be able to see the spatial mesh pop up and how we're able to interact with it. Now that we hooked up our UI and we have the PC built, it's time to test on device. Now this takes a little bit of time to package, but there's a few other options, such as holographic app remoting, which streams your editor view to HoloLens, and the HoloLens will send back sensor inputs. But this doesn't always give you an accurate depiction of how your application runs on device. So it's best to go to File, Package Project, and Package for HoloLens. I normally just save it to my desktop, and now Unreal will start generating an AppX for HoloLens. And once you have that AppX, you can simply sideload it. So now we have everything running on HoloLens 2. I can select the Explore tab, hide the glass, and move our panel over so we can click on a few config options, change the PC to black, get a closer look at all the details, jump back, switch to liquid cooling, and then get another peek at what the liquid cooling config looks like, and jump back to our lighter color scheme. Then I want to place the PC on the table, so I'm going to go into placement mode, which shows the spatial mesh. At this point I can grab the PC and just aim it towards the table, and then tap to place it.
Hey there, everybody. Thanks for watching our webinar. That was a really lovely presentation, Cameron. Thank you so much for all the hard work on that. Covered a ton. It was super fun going through this process. The HoloLens 2 is such a cool, fun device. You know, like think about, you're like wearing this crazy computer on your head. and it's doing all these amazing things. So thanks everybody for the amazing questions throughout the chat. There was some pretty good ones in there. Lots of questions about the performance and what was necessary. So maybe you can expand on that just a bit. Yeah. Nice. So the PC asset was right around 130,000 polys, and it actually seemed to hold up even better when it was further away. And as you got really close, the performance you could feel, or you know when we were speccing it, you could see that it dropped a bit more when more pixels on screen were filling, maybe, or something like that. So it had no problem with the poly count. I have bars going out. Let me try to give it a kick. Yeah, I've got audio bars. So can you guys hear us? Cameron, you want to talk really fast? I hear you, and I have bars for you. So hopefully it's going back out, and we'll know in about 20 seconds if someone hollers at us. Well, I can just repeat what Cameron said. So what he was talking about was the performance and how there is no really hard spec that's 100% defined. So it's really kind of a combination of everything: poly count, shader complexity, overall how close you are to the objects and things like that. So I noticed on this PC, even though the poly count was a little bit above 100,000, it was like around 130, it still held up really, really well. And it was even when you were all the way back and every polygon on the screen was drawing. And as we got closer to some of those internal components, you know, that's where you could feel the frame rate kind of drop down. It was still maintained. It was above the threshold that we didn't want it to drop below, but you know, it was a little bit faster when it was further away, which I thought was pretty interesting. So I don't know if you guys are hearing Cameron when he talked, or are we okay, Matt? I don't know if everyone dropped off the call or if it's just me now. Well, yeah. If not, you know what, I can just I'll kill OBS and we'll start it back up. All right, I'm going to kill OBS and just restart it. All right, so we just rebooted OBS for all of you who are still hanging out with us, and we're going to stay in here and take about 4 or 5 more minutes worth of questions. So a couple of the other questions, and hopefully Cameron's audio is going to make its way out through OBS, because we're getting hot signal on my end, so I don't know why it's not making it out. Talk about remoting a bit, because there was several questions that kind of came up about remoting.
Yeah, so remoting it solves a few use cases. So the first one is if you want to quickly iterate, you can just remote from your editor right to your HoloLens, and then you don't have to worry about packaging up a build and installing it. Then the second use case is if you have a really complex level, you can remote from a PC and stream that PC's video to your HoloLens, and then your scenes can be almost as complex as you can imagine.
Interesting. And is that reliant upon like Wi-Fi 6, or does it go down to like Wi-Fi AC? What's the...
So yeah, the stronger the wireless connection, the better. There's a setting in Unreal to kind of control your bit rate. So depending on your connection, you can kind of dial that up or dial it down.
Okay, interesting. And if you have a machine that's capable of ray tracing at 90 frames a second in 2 eyes, could you technically do that? Like if it was like a really simple scene or something, or you were just hitting the like the lowest roughness values for the bounce rays?
Yeah, I haven't tried that specifically, but I would imagine whatever you can render it in the editor or in a standalone PC package, you could do that.
Well, that's awesome. Well, I'd like to thank everybody again for taking the time to join the webinar. It was actually, we ran right up to the hour here and we're already a little bit over. We are doing another presentation at 2 o'clock Eastern, and we're taking questions throughout the chat during that time also. So if you want to join us at 2, make sure to come back. I'd like to thank everybody again for taking the time to do this. We do these webinars pretty much every month. There are some online learning resources that are being put together for HoloLens, and it's being done jointly with the online learning team as well as the Microsoft folks. So if you want to learn more, you can always go to the online learning portal, which is basically on our website, and there's a ton of curriculum-based classes there for that. So that's pretty much it. I'd like to thank you all again, and we'll see you maybe at 2 o'clock.